Hey everybody. So today I'm going to talk to you about AI agents and specifically why I still don't utilize AI agents for everyday tasks in 2025. I was originally going to make a completely different video than this. I was originally going to make actually a follow-up to my small agents video and kind of make like a beyond the tutorial and real world use cases for small agents. And so I start building that out. And then as I build it out, I run into complications with the build out. And it's just with how it works overall. Nothing bad about the frame. The framework is awesome, right? So small agents, if you are into agent frameworks, small agents is the one that I would recommend. At the moment, it's just the most built out, easy to use. There's a lot of tools and advantages to it, and I like no recommendation. Like I'm like not any paid support or anything like that, right? Like, but just like that would be my recommendation overall. But so going further into this, right? The first place that I want to start is back in 2023. Back in 2023 is when I first thought that this problem was solved. This model comes out, and I, along with a lot of other people, thought that okay, game over, right? We've done it. The world is going to change from here. And then so this model was a model trained to make API calls, and like the very first one. And so this was put out by UC Berkeley. This team originally. Since then, has gone on to Microsoft, and then Gorilla has been part of Microsoft. Like there's a big relationship there. Just highlighting that. And then it's utilized across the board. You can see here it's Anthropic, Weaviate, OpenAI, across the board, right? This became huge and big. And this was early 2023, like February 2023. And then here we are. And we're still solving these same problems and going through these same things. Highlighting, here's my personal contributions to agent frameworks. So six over 3 years, right? And you can see from 2023 up until November of 2024. So even up till recently, right? Multiple stars, multiple different frameworks, multiple different models, right? And multiple different philosophies behind this. And then so there's a lot of people, a lot of resources, myself, Microsoft, I mean, OpenAI, every single company on the planet has been throwing something at this problem for 2 years. And then so kind of like the bottom line that I want to highlight within this up front and make it crystal clear, right, is that if we were actually going to make some significant breakthrough with regards towards everything, all these current existing factors, it would have already happened within the last 2 years. And that's my upfront hypothesis, just flat out. And my thesis throughout all of this is that if you're expecting current technologies without anything changing within this for us to get to AI agents, you're setting yourself up for AI Winter 2 Electric Boogaloo is kind of like how that's going to work out. It's just the bottom line, right? And so let's talk about why that is. There's a few reasons why. I mean, this is a lot harder problem than you would think it is, right? And then so here's the bottom line of the problem. I want to break this up into two parts, right? So this is like problem number one, and then let's talk about this problem first, and then we'll talk about even if we solved this problem, why it still doesn't matter, right? Problem number one is intuition, very simplistically, right? And I just have here the definition of intuition: the ability to understand something immediately without the need for conscious reasoning. A thing that one knows or considers likely from instinctive feeling rather than conscious reasoning. So, whenever I see this in a dictionary definitions, you can always tell that there's a problem with the word and our definition of the word, right? It's intuition is utilizing instinctive to define intuition. So it's utilizing itself to define itself. Because it's a hard word to define. Like, what exactly is intuition? But in this instance, I can just simply say intuition and talk about intuition, and we all know what it is because it's something that we all do as humans, right? We all have intuition built in. What exactly is it? I don't know. It's likely from instinctive feeling. Likely meaning that we don't know. So I don't know. And then even if I did know, the only word that I can actually think of to define itself, this word intuition, is itself instinctive. And then so is inherently problem number one. What is this? Right? Like models in and of themselves right now have a generalization problem. If I teach a model about a certain instance, it doesn't have any intuition to utilize and take that information from that one instance and then bring it over into a brand new instance. Where does this intuition come from? What is this? How do I mathematically define what intuition is? What's the foundational starting point of intuition? So I mean, that's where we're at with this problem, right? And there could be a scientific answer to this question that I don't know about. As a computer scientist, like someone that approaches this from like the computer science and engineering aspect, I cannot answer this question for you. I have zero idea where to even start with this particular problem. So this is problem number one, right? Like, and this is like the golden problem. Let's like nothing else matters because we can't solve this problem. But even if we did solve this problem, what that would open up is a cascade of lesser problems than this problem, but still great problems. And then those cascade of problems work themselves into like bucket number two. So like what is intuition is bucket number one. We move on to then bucket number two, which is how and why the models learn. And this is still being debated, right? So that's fundamental problem number one within this. And then so within this, I have here highlighted 3 different research papers, all academic research papers, all taken from arXiv. XBEL, LLM agents are experiential learners. This is from December 2023. The Apple paper, Understanding the Limitations of Mathematical Reasoning in Large Language Models. This is October 7, 2024, the paper that everyone cites that states that like LLM models don't learn. January 17th, 2025, Towards Large Reasoning Models, a survey on scaling LLM reasoning capabilities. This one is awesome, right? Because it shows, if you read this one, the divide that exists over this subject. Like, what exactly is learning? Are the models learning? How exactly are they utilizing learning? Where do they fall on that scale? All of these things are still question marks that we don't know, right? Like if like how you can't pull the lever if you don't understand exactly what the lever is. And then so right now we don't understand, and I can't prove to you. There's still debate on both sides whether or not this lever actually exists. So that's where we're at on the academic level within this, right? And then, so let's say that we solve that problem. Okay, we say that the models do learn. We accept that as fact, right? So then we do that. We then run into this problem here, which is actually a huge problem. Like this is a massive part of the equation and a massive part of the problem that like no one thinks about until you actually get into this, which is that every single decision that you make can be broken into smaller units, even an API call itself, right? Let's say doing a function. I want you to make an API call to retrieve a piece of information and bring it back. We would kind of instinctively as humans define that as a base unit of action, but that's not a base unit of action to an AI model. Within that, there's 3 different actions. There's planning, there's calling, and there's summarizing. And then so within that, you need to account for these 3 different actions. You need to account for it mathematically within your framework. You need to train the model on it, all these different things, right? And then so this is up front. So number one, the biggest problem that you have is like, we want to do this simple task. This simple task involves three different actions. Like, let's task by OpenAI. That's a very good example, right? OpenAI just released tasks, and then it's like, woo, right? And everybody's kind of like, there's a divide over that because all it's doing is really just being like your calendar. Like, remind me in a week, right? Remind me in 2 weeks. And that's all it's doing. And then you have some people touting this as revolutionary and some people saying like, well, like, yeah, like, congratulations, like my PDF planner from like like my like Palm Pilot from the year 2000 did that. And then so what's new here? And then so within that, it's like, it's hard, right? Even just that calendar function, that task function is hard. It's planning, calling, and summarizing. And then so we're literally just at the point where we've gotten to be able to do this for your calendar function. And then so being able to get it and scale it past that point is another problem entirely, right? And then so here's probably the biggest elephant in the room around all of this. And then I highlight this with this research paper, which is like called "Attention is Not All You Need Anymore." And this research paper essentially is a criticism of the transformer architecture overall, which is a big problem within this, right? And then I saw this problem. I think a few people saw this problem a few years ago, which is that OpenAI and the corporate AI community made a massive bet and a massive gamble at this point. They're all in on transformers. It's kind of like the elephant in the room that doesn't get talked about within these discussions. If transformers is not the answer, if attention is not all you need anymore, OpenAI as a business model falls apart. This trillions of dollars in corporate AI investment at this point falls apart. There's literally trillions of dollars invested in this equation not being true. If you look at it from a pure rational standpoint, you take the time, you understand the mathematics, you understand how these models work. Man, there's an actual reason why the smartest people in the room agree with this hypothesis. It's like kind of that scale, right? Like where it's you have like the like really derpy guy on the one end, and then like the like super like brainy guy on the one end, and then like the guy in the, like the annoying guy in the middle, and then it's like they both the two ends both reach the same conclusion, which is that attention is not all you need anymore. That's where we're at within this, right? And then you have both sides of the equation reaching this same conclusion. And then so when you have both sides, you should really look into that. Like, I 100% at this point am betting against transformers, like flat out. Like there's flawed and inherent flaws within the architecture itself for corporate usage. I've never been on board with LM models for corporate usage. It's like a big thing of mine, like from jump. And like these are the reasons why. Like a big reason within it is like I think that the architecture itself is flawed, and then so I wouldn't want to sell flawed architecture overall to anyone. And then so that's like big elephant in the room here, right? But talking about this and taking this a step further, and or like diving in deeper, I guess a layer deeper. I like this slide to illustrate this, right? Which is like, stupid Oracle can only predict the future with 90% accuracy. And then so the problem is that where we're at with these, and it's going back to this flaw with the current architecture, right? And then so this isn't a flaw. This is a different problem than the transformer architecture flaw specifically. It's a flaw of the architecture of how we're building out AI models in and of themselves right now, which is essentially to predict the next token in a sequence, right? And then so they're predicting, and then so when you make predictions, inherently you're going to predict wrong, and you're going to have inaccuracy within those predictions, but you're going to be able to do maybe like things that you wouldn't expect to be able to do with those predictions. For example, there's a study that they literally can predict like 5 seconds in advance. If they train LLM models and the LLM model can predict, or it's a neural network model can predict 5 seconds in advance what your mind is like, what the brain is thinking, and they train it on brainwaves, right? And then like it's literally is able to predict in advance what you're thinking with over 90% accuracy. Not 100% accuracy though. And then like that's the problem and the difference here. Like the difference between 90% and 100% when it comes to corporate usage is massive, right? Like if I tell you I can predict the future, I can predict whether or not the stock market is going to go up with 90% accuracy. That's huge, right? Everyone is. I'd get a lot of investment for that. If I say I can update your business systems with 90% accuracy, I'm going to get zero investors behind that, right? Same equation, both 90%, but two different aspects, right? And that's the part of this equation that I think a lot of people overlook. Like they want this model to be something that it will never be. It's going to always be less than 100% accuracy. It's built into the mathematics. Sorry, it just is. Probabilistic mathematics inherently means if you want probability, it's not going to be 100%, period. Like you can get it like, and you can distill it out. And I've seen like mathematicians, they try to do this, right? They'll try to squeeze that probability as much as you can. You can, I mean, and you can get it like 98%, 95%. You're still going to have 2 to 5% of probabilistic aspect of that, and you can't eliminate that. That's how the models work inherently. That's the mathematics, right? You need the probabilistic math blended with your linear math in order for it to work, or else it doesn't work overall. And so, I mean, you can't get away from that as a mathematician. So, and then kind of the biggest elephant in the room when you add all of this up to me is that solving all of these problems is itself AGI. That's the bottom line within this, right? If we were able to suddenly and miraculously solve through every single one of these problems that I listed out, this kind of linear chain of problems, you would say that we've achieved AGI or ASI within that. We have a model that can think, can break down problems, can understand what intuition is, utilize intuition. What's the gap between that and AGI? There's none, right? And then so, do you think that we have AGI at the moment? No, I don't think anyone says that would say that, right? So if you don't think that we have AGI at the moment, we definitely don't have agents at the moment. It's kind of the bottom line within this, right? And that's where I want to leave this. The two are hand in hand. You can't separate them. All of this that we've added up and what it adds up to is a formula for AGI. So if you don't think we're at AGI, if you don't think we're close to AGI, then you have to inherently apply that same logic to agents, or else you're leading with emotion as opposed to logic within this equation. And so for all of these reasons, it's 2025 and we have no. If you have content, please like and subscribe. Thank you very much.